Hello everybody, this is Ramesh Pani. In this video we can talk about exponents. Exponents that are natural number are certain notation for repeating factors. In this example, 3, which has been repeated 4 times, which has been written as 3 to the power 4, and this sorted notation is called exponential expression. In this expression, 3 is the base, 4 is the exponent, also called power. Let us discuss some example. In this expression, 3 to the power 4, 3 is the base, 4 is the exponent, the repeating factor is 3, which has been multiplied 4 times, gives 81. The second example, -5 to the power 2. Here -5 is inside the parenthesis, so -5 is the base and 2 is the exponent. The repeating factor is -5, which has multiplied 2 times. -5 times -5, which gives 25. The third example, -6 square. In this expression, 6 is the base, not -6. Look at the previous example. -5 is inside the parenthesis. Here -6 is not inside the parenthesis. Here negative is multiplied with 6 square, which gives negative times 6 times 6, which equals -36. The product rule for exponents, if m and n are positive integers and a is a real number, then a to the power m times a to the power n equals a to the power m plus n. If two exponential expression will be multiplied with common base, the result will be common base and the power will be sum of the exponents. Example, 3 square times 3 to the power 4. Here 3 is the base, which is common for both the expression. Their multiplication will be 3 to the power 2 plus 4. Here 2 plus 4 are the exponent for the two expression. They will be added, which gives 3 to the power 6. X to the power 4 times x to the power 5 Here two expressions have common base, which gives x to the power 4 plus 5, which equals x to the power 9. Some helpful hint: do not forget that 3 to the power 5 times 3 to the power 7 is not equal to 9 to the power 12. We have to add the exponents. Common base not kept here. The common base should be 3, not 9 to the power 12. It should be 3 to the power 12, because the common base is 3, not 9. Here 9, it means 3 times 3 is 9. This is not the correct answers. The correct answer is 3 to the power 12. In other words, to multiply two exponential expressions with the same base, we keep the base and the exponent, and we have to add the exponents. We call this simplifying the exponential expression. Some helpful hint: do not forget that if no exponent is written, it is assumed to be 1. Example: z times z, which equals z to the power 1 times g to the power 1. Here there is no exponent, so it is assumed to be 1 and 1. So when we multiply these two, it gives g square. The power rule: if m and n are positive integers and a is a real number, then a to the power m whole to the power n equals a to the power mn. In this expression, a to the power m, we raise another power n. These two exponents will be multiplied. Example: 2 to the power 3. Again we raise another power 3. These two exponent has been multiplied, which gives 2 to the power 9. X to the power 4 to the power 2, which gives x to the power 4 times 2. This 2 exponent has been multiplied, which gives x to the power 8. Power of a product rule: if n is a positive integer and a and b are real numbers, then ab whole to the power n equals a to the power n times b to the power n. Here ab is the base, n is the exponent. This gives a to the power n times b to the power n. A is the base, n is the exponent, times b is the base, n is the exponent. Example 5x square y whole to the power 3 equals 5 to the power 3 times x square whole to the power 3 times y cubed, which gives 5 cubed is 125. Here x square whole to the power 3, this 2 and 3 will be multiplied, which gives x to the power 6 times y cubed. Power of a quotient rule. Quotient rule. If n is a positive integer and a and c are real numbers, then a over c whole to the power n equals a to the power n over c to the power n, provided that c not equal to 0. If c will be 0, then any number over 0 will be undefined. That's the reason c is not equal to 0. Example, p over 4 to the power 4 equals p to the power 4 over 4 to the power 4. Quotient rule for exponents. If m and n are positive integer and a is a real number, then a to the power m over a to the power n equals a to the power m minus n. Here we have two expressions have common base, then we can write it with common base and the exponent will be subtracted, provided that a is not equal to 0. The base will be 0, or we can say here if anything over 0, then it will be undefined. So example, x to the power 7 over x to the power 3. Here the common base is x, so the quotient rule will be applied here, which gives x to the power 7 minus 3. Here the exponent has been subtracted, which gives x to the power 4. 0 exponent a to the power 0 equal to 1 as long as a is not 0. 0 to the power 0 is undefined, means any number except 0 whose exponent is 0 is equal to 1. If the base is 0 and exponent 0, then it gives undefined. Example, 5 to the 0 equal to 1. xyz cube whole to the 0 equal to 1. Negative x to the 0 equal to negative times x to the 0. X to the 0 is 1. So negative times 1 is negative 1. Thank you.